Hello and welcome back to module number 9. In this module, we're going to talk about the t-test and what do we do with t-test and how do we measure that. And we're going to do a little review of what we covered last time in module number 8. In module 8, we looked at correlation, but we also looked at regression and tried to figure out what is the difference. We said that in correlation, we are trying to measure, or the concern is the strength of the relationship. And we said quite clearly that correlation does not measure the causality that imply in the correlation. In comparison, in regression analysis, we are aiming to explain the impact of the independent variable on the dependent variable. And we declare what is the dependent variable compared to independent variable. We also looked at correlation coefficient, and we lay out and say that it is the strength of the linear association between the variable. And we looked at different type of correlation coefficient, for example, person production moment as a form of correlation, and we saw that what it really means. In regression analysis require the idea of interval and ratio level data, and going back to what we started, we said that interval and ratio data is not the highest, but almost the highest level of data. If your data fits into the model of regression, it usually applies to scatter plot analysis in order for you to show what it is. So there's two conditions that regression analysis is often needs to apply to. One is the type of data, which means ratio level data, and ability to apply that into scatter plot in order for you to see that. The reason for that is that regression analysis assume a linear relationship if there is a relationship or no relationship, and the regression analysis is a little use of that type of data. So in this case, this is what the scatter plot will look like when we will look at type of lines and what type of relationship exists between them. Scatter plot is a linear relationship. Can be positive or negative, and the population again depends, and this is something that we already discussed on that subject while describing descriptive statistics. In regression analysis, we add another element to it, which means a straight line that will give us if the data actually lay out according to the straight line that we are trying to draw from the data. And if it will match, it will be a more accurate reading or analysis of the regression analysis result. So things to remember: regressions are still focused on association and not causality, and this is really important. Second, the association is necessary pre-requirement for causality, and so we are looking at the independent variable and the dependent variable in the same time with that regard. The two variables must be lined up by the theory, and the compiling independent variable must be eliminated. So those are the things that we are looking at when we are applying regression analysis or regression table or graph in order for us to understand where is the distribution of the data in that in this type of analysis. In regression coefficient, it is the slope of the lines that tell us what the nature of the relationship between the variable is or are, and is it a regression coefficient that more change or not. Those are the things that we are looking at we looked at persons R regression analysis to determine how closely the dots are clustered around the line, and this is important for us. It, again, give us some indication about that. The person R is the range of the number is between -1 to +1, where 0 is no linear relationship exists. We have another issue that we need to take, and it's not concern open source R, it's about the R square. And the R square is the proportion of variance in the independent variable that which can help us predict about the independent variable, for example, the level of education. So again, the issue that we're going to see in the R square when we calculate the R square is that the value indicate it's, in this case, 0.542 or 54.2% is that can predict from the variable education, and this will give us a better indication of the association between the independent and the dependent variable. So the R square is also called the coefficient of determination in order for us to see what it is. Another term that also associate with regression is adjust R square. And what it does, it gives us the idea to how it fits into the model and how to explain the variance in the dependent variable are due to change. And so the idea here is that the adjust R square give us where we are standing with the adjustment and how it can play around. With that regard, in this case is 0.542, and that's a R square, and in this case, or in this example, it's the adjustment R square is equal to 0.532. There is no much difference because they are dealing with one variable. So this is something that we need to be aware, and we need to show signals that if we are doing that type of analysis, we need to be very aware of the R square and the adjust R square in order for us to see if we are getting the same result and they are aligned to each other with that regard. Another type of analysis is ANOVA, and this is a little bit more. It's a little bit more advanced regression analysis, and the idea here is that we are calculating the p-value with the f-value, which is a very small portion, and so the values that we try to answer do the independent variable reliability can allow us to measure the dependent variable, and by doing so the p-value is compared to the alpha level 0.05, and if it's similar we can conclude that the independent variable reliable, predictable to the independent variable. So it is basically another layer of measurement to make sure that if we are going to assume that there is some kind of correlation between the dependent and the independent, those tests need to be verified and reported in order for us to conclude. So if the p-value were greater than 0.05, we would say that the group of independent variable does not show statistical significant relationship with the dependent variable, and that the group of independent variable does not predict the dependent variable. Those are the things that we are looking at. So basically, if I will summarize what is the regression analysis, is comparing two variables. So the regression analysis is quite useful for comparing two variables to see whether they are controlling for other independent variables that affect your model. So for the first independent variable, education, as I gave you the example, the argument is more educated we will have a higher paying job producing a high level of per capita income in the state. The second independent variable is including because we expect to find a better paying job and therefore more opportunity for state residents to obtain them. So those are the key components in this module. And again, I did not get into the framing of the questions, but I want you to pay attention to what's going on. We are trying to identify the independent variable with regard to education, and is it result in better paying higher jobs. And so as a result, this is something that we are always trying to do. So the issue is single regression or multiple regression. And again, those are two types of regressions that we are trying to achieve in a model summary. In single regression, in multiple regression, we have the same attributes. And ANOVA, again, what we have, and in coefficients what we have. So multiple regression, typically we want to use more than a single predictor, independent variable, to make this prediction. And regression with one more predictor is called multiple regression. And the formula for that is as I lay out in the slide, which will be able you to understand what it is. Let's take example. Sex discrimination in wages. In 1970, bank was sued for discrimination based on sex. So the analysis of salary of employee of one type, skill, entry level, presented as evidence by the defense. So did female employee tend to receive lower starting salary than qualified male employee? And so what we did was variable collected. We had 93 employees on the data. 61 were female, 32 were male, and we abbreviate what it was the annual salary, what is the annual salary in 2000 during that time in 1977, years of education, months experience at the bank, and female or male. In this case, 1 is a female, 0 if it's a male. Senior, how long the person worked in the bank, and age is month. So basically we have 6x and 1y. However, what will allow us to we would not say in 177. So in this case, I display that in R. And again, the issue is that T result is 6.3 with a p-value of 0.001. So it doesn't control for other characteristics. And as we see, the issue here is that we are able to see that yes, women or female got a lower paycheck than male, and this is discrimination at its best. So again, relationship between them and how it play out and what is the effect of it. In multiple regression, for any combination of value, the average value of the lies on straight line, and that's what we will do in order for us to display that, just like a simple regression. But in this case, we are using multiple regression model in order for us to do that. So this is the outline of the regression, and this is what we came up with regard to the summary. So the predictions, example, prediction of becoming wages for women with 10 months of seniority, that is 25 years old with 12 years of education and 2 years of experience. And this is the formula. Out of it, we'll come up with it. In R, we have also multiple regression. And the function for R in multiple regression is LM. And it is a linear module, which means that the function can be used to create the regression model, and the function, the LM function, accepts a number of arguments. Example, fitting linear module, and it allowed us to explore list of commonly used settings in that. In order for us to do that, we also allowed us to do is formulate the arguments that we want to apply. And again, this is part of the Y variance versus X variance and how it play out in order for us to do that. In multiple linear regression in R, it's also what we do is add another dimension to the analysis, and I will say fit, and I will embed it into the LM, the multiple regression analysis, and I will put up the formula that I would like to examine, the Y and the X1 and the X2 and the X3, and the data is where I will define my data in order for me to show, and I will ask summary fit, and it will show me what confidence level I have, what is the lifted fit into the predicted values. It will show me also the ANOVA table, and it will show me the convenience matrix and the influence with regression diagnostics. All of it part of the R. Next, I need to talk about t-test, and I will give you an example of all those things that I mentioned. I will give you also an example in Canvas. I will not forget that. So t-test is for independent means about population means. And so what does it mean to use t-test? And why do we use t-test at the beginning? And what we use t-test instead of z-test? Those are the things that I want you to think when we are going to explore the idea of t-test. So background about t-test. It's used to test hypotheses about the means when the population variance is unknown. And it's closely related to the z-score, which is a unit of the unit of study. And it's developed a little bit of history. It's always good to know. It was developed by Cosit in 1876, and he used that to qualify or to have a control of beer production, for the beer. So comes here, what he did was he tried to measure 3 variables. So in this case, a single sample, independent samples, and the dependent samples in the idea of the test. So t-test is also known as student test, and it is used to simple test T, which have only one group, and you want to against it the hypothesis mean, or independent test t-test, which we have 2 means and 2 groups, no relationship between the 2 groups. Example, people randomly assigned to a single group. And independent T, which we have 2 means, either same people in both groups or people that are related, husband and wife, or left hand and right hand, hospital patient or visitors, etc., etc. I need to talk about formula that I'm using. I'm not going to go over each one of them, but what you're going to see here in that in this outline is that we are defining the age null hypothesis and what is it entail, and then and if then, in order for us to do that, and it allowed us to also find out about the t distribution. When we use t for the population variance when it's unknown and the sample size is small, the t distribution is a short and usually allowed us to show the shape of the distribution as a df. And so the n becomes in a large and the t becomes norm. df stands for the degree of freedom, and the concept of the degree of freedom is the central concept of the principle of estimation in statistics, and it is the idea behind everything that we're going to do from now on. You're going to see the df. So think of the df as a mathematical restriction that needs to be put in place when estimate one statistics from estimate of another. Let's take, for example, data that have a random number of normal distribution, and the normal distribution needs to have two angles. One is the mean and one is the standard deviation for the definition. So the idea here is that we will have the mu, the sigma, and the sample estimate that are the x bar and the s. So the degree of freedom is again part of the mu and part of our definition, and it is the degree of freedom that are n minus 1 in the equation. And so in this case, the standard deviation of the population, and where the x is the value of the population, the mu is the mean of all x, and the n is the number of x in the population. And so this is where we are coming into play. So for the t distribution, the degree of freedom are always a simple function of the sample size, and one way to examining the df is if we know the total or the mean of all but one score. So in this case, this is how we will do that. In simple single sample test, this is the formula for that. This is the invert or the idea behind that, and the difference between the mean, this is what you will get out of it, and difference between, that's what we will go. The independent sample test, this is what we are, the formula, and this is the breakdown. The independent sample test, again, this is what we will do. The dependent t is the observation come in pairs, and the problem solved by finding the difference between the pairs, in this case what it will include and how it will be applied. One of the things that we need to be aware is the assumption. In t-test, based on the assumption of normality of the variance. So you can test that both those, making sure that you learn the SAS methods, as long as the sample of each group are larger and nearly equally, the t-test is robust, that is still good even though the assumptions are not met. So we talked about a little bit about describing what is the design sense of single sample test and where is the independent sample test, and the strength associated with that. And as the strength is the scientific purpose is to predict or explain the changes that happened. So the strength of the association in this case is the following formula, and we are trying to accommodate or measure the different level of the formula. Associate and significant is the power to the increase of the association with the sample size, and the effect size, and the significant where it is effects size samples is equal to multiplied by sample size. So those are estimate power and how we apply to it. Okay, the most important for us is the function t-test is available, so it will allow us to test the x as our norm and the y as our norm, and we will test the t-test if we'll apply the x and y, which will give us the following resolution. He will give us the t-test result, he will give us the df, he will give us also the p-value, and in addition to that, he will apply if the alternative hypothesis is true or false, and he will give us the percentage of confidence interval, which is between two numbers, minus and plus, or plus and plus, depend. And he will give us sample estimate with that regard. So we can find the exact t-test from the output of the function, so it will give us the idea what it is entail and how to apply that. So if you want the value, name, statist to exact we can use the $ notation or double square brackets, and so t-test, and I will do the $, or I can do t-test and put it under equation in order for us to do that. However, one value does not let us do very much, so we need to generate much more statistics before we will look at the properties. In R, the replica function that makes it very simple. So what we will do in this case is we will going to generate 1,000 t-tests from the testing the two groups in 10 standard random normal numbers. So we will use the TS equal the replica 1000, and we will ask to test it under t-test normal, and we will apply that in order for us to do that. So again, this is how we test it and how we apply to it, and we can test if it's that true in order for us to apply to understand that and understand the range out of it. So I lay out for you what is it entail, how it flow into the distribution, and how another way to explain that. Another way is the QQ plot function, which allowed us to show it in the graph to make it more sense of it. I will lay out, because I did not lay out for you example. I will provide you with example in Canvas, so you will have better sense what it is and how to apply to it. And so again, I want you to go, I will lay out for you a reading material about the t-test, and I hope it will make sense. You can also use the destiny in R to apply that and how it come about. And that's it for now. I hope you enjoyed that. I know it's going to be hard. I will try to give you much more in-depth in Canvas. And until then, if I will not hear from you, if you have any question, please let me know. I will try to give you more R codes in order for you to understand that. Until next time, have fun.